Hey, Miss Marion here. We're going to go ahead and talk about Unit 4, Lesson 2. And so make sure you jot down some notes while we're doing this. Make sure you understand it. If you don't understand something, pause it, go back, and redo it. But this is what we are doing for today. All right, so get us ready. Let's go ahead and turn to page 14. Let's kind of do the jump start because our brain's going. It says quantities are attributes that can be counted or measured, such as a dozen eggs, 25 miles, or 60 minutes. Notice that the quantities always include a unit of measure, eggs, miles, minutes. Some quantities are derived from combining other measures, such as miles per gallon or feet per minute. It says, describe how you would measure the fuel efficiency of your car in minutes per gallon. So go ahead and answer that and then come back to me. All right, so to be able to find your car's fuel efficiency, we are going to go ahead and you do the number of miles driven per, that's what this fraction line, so per the number of gallons of gas. And I know right now you're just like, well, okay, that's great. But other people, when you buy new cars and that kind of stuff, you really want to kind of know the fuel efficiency. So, are you going to be spending a lot of money on gas or not? All right, let's look at number 2. Describe how you would measure the speed of a baseball in feet per second. So, feet, okay, so think about it. It's going to be distance traveled. This is of the baseball. Per, so we're making that fraction. I just don't have a lot of room to write it in there. Per number of seconds. All right, describe how you would measure the area of a rectangle for the room. So we're thinking about a rectangle. We have length and width. How do you find the area? Oh, that's going to be our length multiplied by our width. And then the last one is describe how you would calculate the revenue collected by a roadside fruit stand if they sell 20 bags of oranges per $5 bag. Think about that for a second. All right, so it's $20 per bag. Or sorry, they're 20 bags. And we're going to multiply it by $5 per bag. And that will give us how much they do, right? How much is it? Yeah, they were able to get $100. So this is actually starting to get us to think about different measures, different things that we go ahead and calculate different things, because we're going to use this with Elvira stuff. So our goal today is, what does it mean to solve an equation that contains multiple variables? And then how can I use descriptions and units associated with variables to guide my thinking about solving the equations themselves? So we're really looking into thinking and understanding how to solve equations when we have more than one variable, actually. And so we're not just going to have y equals 2. We're going to have other things as far as answers. So kind of keep that in mind while we're doing this. All right, on page 16, let's go ahead and kind of figure out what's going on as far as different things, and then we're going to kind of walk through some stuff. So it says, Elvira, the cafeteria manager, likes to keep track of things she can count or measure in a cafeteria. She hopes this will help her improve the efficiency of the cafeteria. We've all been in cafeteria line. It takes forever, right? How can they make it better is really what they're looking at. To remind herself to keep track of the important quantities, she's made a table of variables and descriptions of the things she wants to record. Here is the table. So this is on page 16. We have this table themselves. And so let's kind of look at it. So we have number of students who buy lunches in the salad. So what would be the units that we're going to go ahead and use on that? Well, that would be students, because we're keeping the number of students. So our unit is students, right? W is number of students who buy lunch in the sandwich line. So what are we keeping track of? What's the numerical value? Again, we're talking about the students, but this is the lunch line. And then we have, next is, we have P is the number of students in the pizza line. So what would the units be? We're counting the number of students in that pizza line. And then we also have, look at F. F is number of food servers in the cafeteria line. Okay, so what is the unit? We're talking about servers. And you should be writing this down because we're going to be using this a lot today, okay? And then we have number, so we have MT, end of T, so it's just kind of a way of measuring this. It says the number of minutes it takes to serve the lunch. So it's minutes it takes. So, okay, what is our unit? We're looking at that in minutes. All right. And then we have C is the number of classes in the school. So what is unit? It's we're looking at classes. Okay, so we this is a way we're actually going to go ahead and figure out many different things as far as, okay, what are the measurements? What they are? So we also have P of L. It says price per lunch. So what is the unit? We're going to write this as a fraction. So price per is that fraction line, and then lunch, well, okay. So we have it as price per lunch. Actually, I'm going to write this in a different format. So we have price per lunch. Okay, so think about, okay, price. What quantity would we use for price? Oh, that's dollars per. And then lunches, well, for selling lunches, we're actually really kind of talking about students, right? So it's dollars per student is really what we're looking at when we're talking about price per lunch. Okay, awesome. So now we're going to go ahead and we have all this filled out. This is actually going to kind of determine. So we've done number one. It says determine the units that fit the third column of the table for each of the variables whose descriptions are given. So these are all the descriptions that we have. And so this is as far as we can. We have all these descriptions. We were looking at the units. We wrote them down, right? And then we're going to use this further to kind of understand some other equations that Evaluator actually used, okay? So let's look at number 2. It says Elvira has written the following equation to describe a cafeteria's relationship that seems meaningful to her. She has introduced a new variable A to describe this relationship. So notice how we have this equation A equals S plus W plus P, and then all divided by C. So S is the number of students in the salad. W is the number of students in the lunch line, sandwich line, right? And P is the number of students in the pizza line. So we want to kind of figure out, okay, so, and then C is the number of classes in the school. So if we're adding stuff up like this, that is actually what and then we divide it by a number. This is actually what is considered an average. So if we're, okay, and so we're doing an average, and we're doing S, W, and P. S, W, and P are students. Okay, so we have total number of students. That's on the top, and then we have this per line, right? It's the fraction line, and then C is classes, right? So we kind of had to think about that a little bit further, but as far as, yeah, if we put it all together, this A represents, so this equation represents pretty much the average of the total number of students per class itself. And so let's go ahead and let's write that in the top, the table where A is. So let's write that down. So we have average of students per class. And the unit is going to be students per class. All right, so now we're looking at number 3. So notice how this average kind of stuff is filled in. So it says, using what you know about manipulating equations, solve this equation for S. Your solution will be of the form S equals an expression. Remember, expression, it doesn't have an equal sign with that. And then written in terms of the variables A, C, W, and P. So we're taking this equation and we want to, so I'm going to move this up first of all. So let's move this up and I'm going to rewrite it to give myself more room. So A equals S plus W plus P all over C. So I want to get, I'm going to circle what I want by itself. So I want S by itself. So let's figure out. So what do we need to move first? So I'm going to go ahead and get rid of the C. So C is dividing everything here. So we're going to do the inverse operation of division, which is the multiplication. So it's a multiplication property of equality, meaning that I can go ahead and multiply each side by C. It's still going to be equal on both sides. And then C divided by C, cancel each other out. What's left over? We have S plus W plus P. And then notice how we have A being multiplied by C. And we can write it either way, either A, C, or C, A, but when they're sitting next to each other, it's multiplication. So, okay, now I want to go ahead and I'm still circling that S. S is what needs to be by itself. So how do I go ahead and who do I need to move? Well, it doesn't matter who we move first. I'm going to move that W. So W is adding. So again, we're going to do the subtraction property of equality. So again, we're going to subtract off stuff together. Notice how we still have AC, and then now we have subtract off W because we can't combine them together. They're not exactly the same. S is still there. We still have the plus P. Again, S is what wants to be by itself. Okay, so I have plus P. Okay, so how do I get P by, S by himself? I'm going to do the opposite. Again, it's the subtraction property of equality. I mean, I can do it on both sides. And then notice how we have, okay, I have AC minus W minus P is all going to equal that S by itself. And notice again how I cannot combine the W and the P with the A and the C. They're not all the same kind of variable. And so they are, they're just kind of part of that equation. This is actually our answer. It's really kind of weird. And a lot of people have a hard time with it. But it is S by himself. Yes. Great. So this is our answer. And remember, it's not just an answer of S equals 2. This is an expression. And it's okay to have this in math. All right, so number 4 says, does your expression for S make sense in terms of the meaning of the other variables? Explain why or why not. So kind of think about that. Right, jot down some notes, and then go ahead and come back to me. All right, so let's kind of think about it. Okay, so we're looking for S. S is total number of students in the solid line. We have AC, we have P, and we have a W and then P. So AC, okay, so we kind of talked about that earlier. A is the average of students per class. So this is pretty much like the total. Remember, it was total number of students per class, or it's the total number of students. W was the total number of students, or the number of students who buy a sandwich. And then P is the number of students who buy pizza. So pretty much we're taking the total number of students. And from there, we're going to take out the students who bought a sandwich. And then we're going to take out the students who bought a pizza. And then what is left over? The students who bought solid. So this is actually a way of actually showing, okay, take all the total number of students, take off those who have a sandwich, those who have a pizza, and then we're going to have the salad left over. All right, so here's another one to go ahead and explore. We have this R equals PL multiplied by S plus W plus P. So we want to figure out, what does all of this actually mean? And so go ahead and pause right now. Think about what this actually means, and then come back to me. All right, so let's kind of put the units with there. So we have P of L. So notice on the table we have P of L, that is price per lunch. So it's dollars per lunch. I'm just going to put the units in there. So I'm going to say dollars per lunch. And it's going to be multiplied by the students. So salad, students, plus sandwich, which students, plus pizza, students. Okay, so if we think about it in a way, so we have the salad students plus the sandwich students plus the pizza students multiplied by the dollars per lunch, or it's dollars per student. Oh, let's put student back down there because that was also another. So it's dollar per student. So aren't we actually looking at pretty much the total amount of money collected? Because we have dollars per student and we're multiplying it by student. Student divided by student kind of cancel each other out. So we're actually looking at the total amount of money collected, actually. Okay, so let me kind of show you again. So we have R equals like dollar signs per student. If we add all the students together of all the different three lines, it's times student, right? And remember how we have to have like student on the top and student on the bottom. We can cross it out and then just dollars left over. So it's the total amount of money collected. And what is the units that's all on there? It's dollars. All right, number 6, using what we know about manipulating equations, solve this equation for piece of L. Piece of L, that's the price per lunch, right? So we want to get piece of L by itself. Okay, so go ahead and pause, go through that, and then come back to me. All right, so I'm going to rewrite this. I'm going to have R equal P of L, S plus W plus P, right? And I know that these two are multiplying. So I'm going to divide by that whole group because I can't add S and P and W together. Like right now, they're not all the same variable. I can't put them together, but I can divide by that whole big group. Okay, so we have R divided by S plus W plus P, and that is going to equal piece of L. Okay, so we're looking at this thing, we're trying to figure out what's going on. Oh yeah, so we solved this for piece of L, right? And it says, does your expression of P of L make sense in terms of meaning of the other variables? So it's dollars. So remember, P of L is price per lunch. So it's price per lunch. So we have R, which is the total dollars collected. And we're adding all the students together. So yeah, it's dollars per student. Dollars per lunch or per student. So pretty much all these like different variables are saying the same thing that we learned before. All right, that's kind of cool. All right, still on page 17, number 8. Elvira noticed that she uses the expression S plus W plus P a lot in writing other expressions. She strives to represent this expression using the variable t. So, okay, I'm going to highlight that. I'm going to underline it. So t equals s plus w plus p. What does the t represent in terms of the cafeteria? So think about that, write that down, and then come back to me. All right, so if we have S as students who have a salad, W is the students who have a sandwich, P is the students who have the pizza. There's only 3 lines. Oh, so T is actually the total number of students who eat lunch. So what would be the variable? What would be the unit? Well, sorry, what would be the unit? The variable is T, so unit is students, right? If it's total number of students, we're looking at students. Awesome. All right, so we're still looking at page number 17. Elvira is having a meeting with the staff members who work in the lunchroom. She created a couple of new equations for the food servers. So we have this d sub f equals t times p of l divided by f. And then we have m equals p of t divided by t. So we're trying to figure out what d of f actually equals. So look at what we know, what we see, and then see what it actually represents. Go ahead and do that, and then come back to me. All right, so I'm going to do the one, seems a little, so f is the number of servers. So I'm going to put servers on the bottom. That one's easy. Servers. Okay. T, let's look for T. So T in here is total number of students. So I'm going to say total of students. And that's being multiplied by P of L, dollars per lunch. So we have dollars per lunch. Or how about that, well, lunch, right? It's dollars per student, actually. That's a little bit better. Let's do that one. Dollars per student. So if we have, and that's total number of students. Okay, so we have total number of students multiplied by dollars per student. So students pretty much going to cancel each other out. Oh, so this is actually, so yeah, so we're having, if we look at the top, there's like, there's on the top and the bottom. Okay, those two cancel each other out, all right? So pretty much it's dollars per servers. So D sub F is dollars per server. Or the total amount of dollars per server. So dollars per server. So dollars per server. Cool. All right. And Elvira would want to know, like, okay, what's going on with the servers? Like, how much money are they bringing in? What's going on? These are things that a cafeteria manager would actually look at. So this kind of makes sense why she would actually make this equation. And then we have this M equals M of T over T. So M of T. So go ahead and pause this, figure that out, and then come back to me. All right, so M of T, if we look at it, that's down here. It's minutes. Okay, so we have equals minutes. And it's minutes it takes the servers to serve lunch at school. And then divided by T, T is student. So this one is actually, oh, how long does it take, minutes per student to go ahead and pretty much buy lunch, actually. So it's number of students, or sorry, it's number of minutes to serve students. So this is how we figure out how long lunch is actually. It's like, oh, how long is it going to go ahead and serve all these kids? Plus, kind of let you guys have some time. So it's going to be minute per, well, let's make that nicer. You can actually see that. So minute. Per student. Cool. So notice how we have all these different variables. We're able to kind of figure out what's going on along with these things. And, you know, it goes along with Elvira and what she's trying to do as a cafeteria manager. All right, so number 9 says we're going to take the equation and we're going to solve it for P of L. So I'm going to move this up. Let's rewrite it and let's talk about it. So go ahead and solve for P of L. Get that one by itself. And then come back to me. So F is multiplying. F is dividing. So we're going to multiply. So multiplication property of equality. So now we have F times D of F equals T times P of L. And then we're also, again, we want P of L by itself. Okay, so then let's divide by T. So we have F times D of F, all divided by T will equal that P of L. Okay, so P of L is the price per lunch. F is the servers. D of F is the dollars per server, and then T is the time itself. So pretty much it's looking at, yeah, this is dollars per lunch, and it has to deal with the servers. Well, the servers are serving students. So yeah, that kind of makes sense of taking these variables and solving for it. Number 10, we're going to take M. And what does the M represent in the cafeteria? Okay, so, you know, we talked about this earlier. We actually looked at, it was a number of minutes it takes to serve lunch. So we have minutes. Looking at our table, T is student. So it's minutes per student. So we can go ahead and put that in our table. So we can write it down. It's a number of minutes to serve. You know, and we've done that actually. Okay, so we did this earlier actually. Sorry about that. But then number 10B, it says, does it describe what, we're going to take this and we're going to multiply, solve it for T. So we have M of T, T. I want to get T by himself. Well, that's division. Let's get the T out of the division. Let's multiply by T on both sides. So we have T, M of T. And then let's get T by himself. So let's divide by M. So T is going to equal M of T divided by M. Okay. So T is total number of students who eat lunch. We are looking at M of T. M of T is the number of students at minutes it takes to serve the students over M, which is minutes per student. So yeah, that would actually give us our time all together. So notice again how this totally helps us understand, again, what's going on with Elvira. All right, so number 11, it says, one of the staff members, on page 18, right? One of the staff members suggests that they needed to write expressions for each of the following sentences. Using the variables in the table, what would you express these look like? So A, we're going to do both of these together. So A, the average number of students served each minute, and B, the average number of minutes students wait in line for pizza. So use the table and write those expressions. All right, so we're talking about average number of students, right? So we only have 3 lines. So we have a salad line, sandwich line, pizza line, served each minute. So and then we're going to have it over minute. Minute was, which one again? Oh, yeah, number of minutes takes to do students. So notice, so minutes, right? So it's going to be M of t. Now, is there another way we can go ahead and write this? Well, yeah, actually, in a way. So notice how t is the number of students. So we can put t as the number of students over m of t, which is the time it takes to serve a student. Okay. And then b was the average number of minutes students wait in the pizza line. So we have students in the pizza line. That's p. And how long it takes for them to wait in the line. So which one is waiting in the line? Or the number of minutes to serve those? Oh, that's m. So notice how we're able to go ahead and take these words and actually make it into an expression where it represents what's actually going on. So today we're looking at different expressions and understanding what all the variables actually mean in that expression and if it goes along with an actual story, which is Elvira's cafeteria manager kind of stuff. So some takeaways, equations that involve multiple variables are called literal equations. One of the variables in the equation represents meaning quantities, and so they're also referred as formulas. We've seen formulas before, and they actually go along with different quantities themselves. It says, to solve a literal equation or formula for one of the variables, I can, and I would write this down, use inverse operations with the variables in the same way I used inverse operations to solve linear equations in one variable. So inverse operations, opposite operations. I would write this down in your notebook to kind of remind you, okay, this is what we actually learned today. This was our goal for today. A second takeaway is if the variables in the equations represent meaningful quantities, I can use the units on the quantities to guide my equation solving process. And we can verify processes by checking the meaning of the expression in the equations after applying the terms of the solution process. So yeah, we were looking at the equations and then we looked at those variables and we talked about, oh, does this actually mean what we're actually looking for? And then this third takeaway, when determining the meaning of an expression that contains multiple quantities, I need to attend to the units and operations. Some strategies for doing so include choosing units that allow a meaningful and useful operation to be performed, and making sense of the units in terms of its content. So we actually went back and we looked at all these different variables and did it actually mean what was actually going on? So that was our goal today, to kind of understand, like take these equations, these expressions with those variables, and actually figure out what they actually mean, not just, oh, we're just dealing with all these variable kind of things itself. All right, so to help us go ahead and do our homework for today, we're going to take different equations. We're going to solve them for the different things. So we go ahead and do number one, solve R for R. So we have D equals RT. We'll use solve for R. All right, I'm just going to rewrite this to give myself more room. So if anything's sitting by each other, that's multiply. Right, and we want to get R by himself, we have to move the T. They're multiplying, so then we're going to divide by T. So then R is going to be D divided by T. Number two, solve for W. So go ahead and do that, come back. So when I get W by himself, who is by W? That is 9. 9 is adding, so we're going to subtract. And again, we're going to make it look nice. So we have L minus 9 equals W. All right, and then number 3, solve for N, get N by himself. All right, so this one's a little bit different. So notice how we're multiplying by 1/3. So it's pretty much this. We're multiplying by 1/3. So how do we multiply by 1/3? Well, I get rid of it, so we're going to divide by 1/3. So think about fractions. If we're dividing by a fraction, remember we can flip it and times it. Or you can kind of think about it, okay, let's get rid of the 3. Let's multiply by 3 on both sides. 3 divided by 3 is 1, leaves 1n. How do we get 1 by himself? We're going to divide by 1. 3b divided by 1 is 3b. So we have n equals 3b. Also, to kind of help us along with different things, we have domain and we have range. Oh, that was 8th grade stuff a long time ago. All right, so think about it. What is domain? And then what is range? So the domain is actually our x values. And range is our y values. So we have to look at this and we have to think about, okay, the x values. So we look at this point and we look at this point, but we're looking at the x. So the x's go from -5 all the way up to 7. So our domain, and so and it's done a little bit differently too. So domain, we have these brackets, and that means we include the -5, comma, and then we're going to go all the way up to 7. And then for range, that was the y's. So actually, you know what? I'm going to put the range in a different color so I can show you. Let's do the range. So that's the y's. So we're going from this point up to this point, okay? But that's the y stuff. So it kind of starts here. It goes all the way up to there. So where does this start? Y value wise, oh, it starts at -4. And we'll go all the way up to 6. So domain are x's, range are y's. All right, last thing, let's graph an inequality, right? So this is, so we have x is greater than -3. So greater than does not have the line underneath it. So is that an open or closed? Think about it for a second. That's an open circle at -3. So -3 is here, open circle at -3. And then we're saying everything greater than -3. So think on the number line, which way will that be? Oh yeah, that's going to be to the right. So this is our x is greater than -3. All right, so again, we're going to do our check our understandings. Make sure you're getting into Canvas because, again, it does different questions along with that. And I hope you have a good day. Thanks. Bye.